In 9.3.2, we're going to express the general, the nth term of a geometric sequence. So in 9.3.1, we defined the geometric sequence in recursive form. But what if I want to jump to any term without having to write every single term before it? So I want a general formula to get that nth term. Okay, so let's look at what that pattern looks like. So if I have n and some geometric sequence term an, so if I start that, my first term, of course, is whatever a1 is. In my second term, I take that a1 and I divide it, I multiply it by the common ratio. And then my third term, I take whatever is here and multiply by another common ratio. So I take that times common ratio, which is really a1 times r squared. And then to get the fourth term, I take whatever's there, so this right here, a1 times r squared, and multiply that by another common ratio. So now I have r cubed. So following that pattern, I take the term above and multiply by r, and I get just adding 1 to the exponent for r each time. So notice the pattern here. My ratio, my exponent of my ratio, is always 1 more than the term it is, the n. So I can rewrite that formula. So I can just, the nth term then is going to be equal to that. I should say this is a1, sorry. That should be a 1. So I start with the first term, and multiply that by the ratio n minus 1 times. And then I can get any term. So that's this formula here. So that's for n greater than or equal to 1. Because notice we have to have that first term and the ratio, and then we can find any term in the geometric sequence. All right, so let's apply that to 17 to 24. So you're doing 17 through 29 every other odd. So we have 2 sections in here. So for 17 to 24, I have an example number 18. So remember our formula is I can find any element by taking the first element of the sequence and multiplying it by the ratio to the power of n minus 1. So here my first term is 12. My ratio is 3. So my nth term is 12 times 3 to the n minus 1. And they didn't tell me what n was. I just want to keep it general, just that formula for the nth term. So that is my final answer for 18. Okay, let's do 21. For 21, my a1 is 1,000. My r is 0.5. So I can write a general term for the nth term to be 1,000 times the ratio. I'm going to put that in parentheses. To the n minus 1. I just put it in parentheses because I have the decimal and the multiplication sign, and with handwriting sometimes that gets a little hard to read if it's not perfectly written. All right, so there we go. That's 17 through 24. So you're going to try every other odd from that section on your homework. Whoops, sorry. Every other odd. And then going on to 25 to 30. I think yours starts at 27 in this section. We're looking for a specific term. So this time they're giving us the n. And we have to find the a, the r, and the n. So we have, I'm going to copy that formula down though. We're still using this formula. So I need n, a1, and r. So here the n, we want the 10th term, so n is 10. And then the A1 is the first term of the sequence, which here is the 1. And R is the ratio, so going from 1 to -5, I multiply by -5. Going from -5 to 25, I multiply by -5. Or you can always use that ratio, which do the -5 over 1, or 25 over -5. And you can find that the ratio, that common ratio, is -5. So now that I have all three of those numbers, I can plug that in and find that the nth term is A1, which is 1, times the ratio, which is -5, to the power of n minus 1, which is 10 minus 1. So that equals 1 times, I'm using parentheses now because I have the negative sign, so it helps me remember that that negative is part of what's going to the exponent, to the power of 9. 5 to the power of 9, I'll put in my calculator, and I get a 9's negative, so it's going to be negative 1,953,125. Now 28. So we want the 9th term this time. So that means n equals 9. A is my first term, which is the 100. And R, I should probably have checked that it's a geometric sequence before I do this, but let's see. My common ratio here should be 100 over 20, which is 5. Let's see if that continues. And then 20 over, I did that backwards, didn't I? I did. So it goes with the second term first. Second term over the first term, so it's 1/5. And then, which makes sense because we're getting smaller, not larger. And then 4th over 20, that's 1/5 also. And then 0.8 over 4, which is also 1/5. So I can see my common ratio is 1/5. Okay, now I can plug those three numbers into my formula for the nth term, and I get, you know what I should have done on this one too? When we're plugging it in, I actually want a to the 10th, not a to the nth. And on this one, I want a 9th. Okay, so my A1 is 100, my R is 1/5, and my n minus 1 is 9 minus 1. So I can rewrite that as 100 times 1/5 to the 8th, which I'm going to have to use a calculator for as well, which I get, well, my calculator gives me a bunch of zeros, very, very, very small number. So to express that one, I'm actually going to use scientific notation. I'm going to take my decimal place and move it 1, 2, 3, 4 points. So I have one significant digit before the decimal, and then since I moved it over, that means I multiplied by 10 to the -4. So I have 2.56 times 10 to the -4 is my final answer. That's a wrap for 9.3.2.